This is Algebra 2, and we are doing the homework for the challenge trigonometric problem that we had from class today. Again, the setup is we have a 76-degree angle, a 28-degree angle. We know that this side is 7, this side is, well, one we're trying to find, we're calling it x. But the problem is we don't have a 90-degree angle. I've been telling you over and over, in order to access trigonometry, in order to use SOHCAHTOA, we need a 90-degree angle. We already saw the hint in class, which was to draw an auxiliary line, which is a fancy way of saying add your own line, right here, and if you add an auxiliary line right here, you have a 90-degree angle. Both this angle and this angle are both 90 degrees, and with that you can access your trigonometry. So I'm going to start on the side with the most information. Again, on the left hand side I only have 28 and I don't know any of these other ones, so I only have one piece of information for this triangle that lives on the left. But for the triangle that lives on the right, I'm going to go ahead and redraw that so you can see it a little bit easier. I have a triangle that looks kind of like this. Right about there and there. I have this triangle with a 76-degree angle, and I know this length is 7, and I can choose to find either this length or this length. Finding that base length might be helpful, but I think what's really helpful is to find this middle length because it connects to the other triangle, this triangle on the left. So let's go ahead and find this length. I'm going to label it some variable. I'm going to call it y because I've already used x. All right, how do I find y? Again, you can use trigonometry. You can say, okay, across from 76 degrees is going to be my opposite angle, and then the hypotenuse is opposite of the 90-degree angle, so I say that this is my hypotenuse. And if I set up SOHCAHTOA, let me write out that's not how you write SOHCAHTOA. SOHCAHTOA. You'll see that because we are not using the adjacent, I should be crossing off the adjacent here and here, meaning I am going to have a sine. So I'm going to say sine of my angle of 76 degrees here is going to be equal to my opposite over my hypotenuse, my y divided by my 7. So I can say this is equal to y divided by 7. And then I want to solve for that unknown side length. I'm going to solve for y. Getting rid of the 7, I'm going to multiply both sides by 7, or using that diagonal trick and bringing the 7 up here. Either way, you're going to get y is equal to 7 sine of 76 degrees. And again, I can do this whole thing without a calculator and leave my answer unreduced, and that's the whole plan, is to not use a calculator. So now I have this length. I can go ahead and label this. This is going to be, let me turn my iPad to the side, and I can say that this length is 7 sine of 76 degrees. I don't know what number that is, but it is that number. And now that I know this length, I have two pieces of information, and whenever you set up a trig function, you'll have 1, 2, 3 spots. If I have two pieces of information and one unknown, I'll have two pieces of information and one unknown. I don't know if it actually goes there or not. It's probably actually going to be down there. Okay, so I can set up a new trig function for this triangle on the left. So let me go ahead and kind of copy down that triangle on the left. Let's go down like right here. I can say that this is the triangle that's on the left, and I happen to know that this length is 28 degrees. This is the one I'm trying to figure out, and I know that the one that's coming up here, I'm just going to call it y for now because I don't have enough room to write, but it is a 90-degree angle, therefore I have access to trigonometry. What is the trig function that relates the opposite and the hypotenuse? Again, opposite and hypotenuse is SOHCAHTOA, it's sine. So I can say over here, maybe I should change this to a different color because I've done everything else in red. Let me change this to a new color like blue, no, purple. I think that's purple. And then from there, you're going to say that sine of 28 degrees relates y and x. You can say that's equal to y over x, but we know what y is. We know that y is 7 sine of 76. So let me replace all of you with a 7 sine of 76 degrees. And then I can make that a giant fraction. And then again, I can solve for x. I can switch these two diagonals using my little shortcut, and I can say that x here is equal to 7 sine of 76 degrees, all that divided by sine of 28 degrees. And I found x. It's whatever that number is. I can plug it into the calculator, but I don't really want to. I just want to say that's how you find it. So how do you do this in general? How do you do this every single time and faster without going through this entire process? There is a shortcut, and I want to talk about in this video. If you want to stop right here and just be like, I solved the homework and that's good enough, well then that's sad because I hope that you have a search for truth like I do. But let's go ahead and push for a general solution. You do not need this for your homework assignment, but this is just there if you want to learn extra. We will be talking about this and you'll just have like a head start in front of everyone. So just like before, I'm going to draw my auxiliary line right down the center, and I want to create a formula that somehow relates these 4 angles together. So the way that I do this is exactly the same as before. I create my 90-degree angle, and I say that I'm going to do sine of this angle. I'm going to call this that my angles Greek letters. So I'm going to do alpha and beta, and then opposite of my beta is my capital B. Opposite of my alpha is my capital A. I switch to normal. What do you call it? Hindu, Arabic, whatever the normal English capital letters are going to be. So I'm going to, again, set this up. I'm going to say sine of beta is going to be equal to, okay, I need to call this thing some letter, and I'm just going to choose x because I'm very creative here. And I'm going to say that sine of beta is going to be x divided by a. Same thing as the last problem. I'll say x divided by a. And in order to solve for x, to solve for this angle, I'm going to get rid of the a and move it to the diagonal top left. And I'll say that a times sine of this angle beta is equal to x. Cool. What about the one on the left? This one on the left is going to be doing sine again. I'll say sine of alpha. So I'll say sine of alpha is equal to my opposite divided by my hypotenuse. It is going to be equal to x divided by capital B. And again, I want to solve for x. And you'll see why in just a second. But if I move this b to the top left, I will say that x now is equal to capital B times sine of alpha. Okay, so if I know that my alphas are getting a little bit twisted here, I can go ahead and make that a little bit better. Okay, so now that I have x is equal to b times sine of alpha, and x is also equal to a sine of beta, x is equal to x, which means I can do substitution here. I can say that since this x is b sine of alpha, this x over here must also be b sine of alpha. So I can make my substitution. I'll even draw a line for you guys to say I'm doing this, and I'm plugging it into that x over here. So I'm going to rewrite this. This is now a sine of beta is equal to b sine of alpha. And there is a formula. That's not the one that is usually in textbooks, though. While this is a true formula all the time, regardless of what these angles are, as long as you're talking about a triangle in the second dimension, and I guess on a plane as opposed to a sphere or anything weird, these are going to be changed just a little bit. I want to move the b to this side because the b and the b will match up. It's technically a beta, but the beta and b will match up. And if I move the a to this side, the a and the alpha will match up, and that's easier to memorize for most people. So this is what you do. You divide both sides by a to move the a. You divide that side by a. And then in order to move this b, I also divide by b. Divide by b, divide by b, and these b's also cross cancel, and you get the final formula that you'll find in textbooks, which is sine of beta, you should be careful here, sine of beta all over capital B is equal to sine of alpha all over capital A. And this assumes that in your triangle that the opposite of a letter that looks like B is B, the opposite of a letter that looks like A is A. And indeed, if you had a secondary letter, maybe I can do, I'll do like a lowercase c. I don't think there is really a lowercase c. There's gamma, but that's not really a c. Maybe I'll do epsilon and e. How about that? There's an epsilon here, and I'll do capital E over here. If I did epsilon and E, you could extend this formula even further to have the full law of sines. And you could say that this is also equal to sine of epsilon all over E. And in general, this is known as the law of sines. And again, we will be going over this in class, but this is called the law of sines. And it's a shortcut whenever you have either two angles and two side lengths, or somehow one of those is missing. So like usually you'll have a formula that looks like this. Sometimes you'll know those three, but you don't know that one, and therefore you use the law of sines. It's really useful whenever you do not have a 90-degree angle in the triangle that you're working on, although there is a law of cosines that we'll be talking about shortly as well. That does conclude the law of sines part of this homework, and you've seen the homework answer as well. I guess I could type this into the calculator to see exactly what it is, but I don't really care that much. I just cared about the process. That concludes the video. I'll see you guys later.